Last one, heat of reaction, a nice neutralization reaction. There's our acid plus our base goes to the salt, sodium chloride, plus water. Okay, so again, we're using the standard coffee cup calorimeter. We're going to take, first day, I believe you used 1 molar sodium hydroxide and 1 molar hydrochloric acid. You didn't get the best temperature change, so we made it up to 2 moles of sodium hydroxide, 2 moles of hydrochloric acid. At this point, this meant you should really wear gloves for this. But anyway, that's beside the point. Take 52 mils of the sodium hydroxide, 50 mils of the HCl to it. Now notice I've put both of those in the pretty blue, because our assumption is that there's no volume change here. So you have 52 mils of water, another 50 mils of water. That's the water that we're going to measure the heat change of. Okay, so 102 milliliters, which we will assume is of course 102 grams. So remember that when we get to it, 102 grams of water. Placing these two side by side till they get to the same temperature, pretty much that's almost redundant, because they will have been in their bottles in the same lab and so on, but make sure you do that for at least 2 minutes of data to make sure you get that temperature consistent. The HCl was in a beaker, the sodium hydroxide was in the calorimeter, so we add the HCl quickly in there, stir it, blah, 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 and then do the same thing. Plot the graph of time along temperature to get the maximum minimum temperature and calculate the molar heat of reaction. Okay, so very, very, very similar to what we did last time. Instead of putting water in there, putting a solid in there, we've got an aqueous solution in there, putting another aqueous solution in it. Here are the data. So again, room temperature 22 degrees, added it after 2 minutes, temperature shot up, look at that, 22 to 51.8, blah, 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 measured enough of it so that I could get that best curve. Plotting it along my nice little Excel, time on the horizontal, temperature on the vertical. There's the 22, 22, 22. I added it at 120 and it shot on up there. So let's do the same process for the graph. Added 122, so make our vertical line for that. Take now our best fit, and of course this is now a cooling process because the temperature went up and is now cooling down. Take the best fit, see where the two lines cross, and this is a good approximation for what the maximum temperature would have been if everything had happened nicely and stirring when I added it. And so that maximum temperature is 52 degrees Celsius. Okay, so bits of information we need so far. We have 22 degrees Celsius to 52 degrees Celsius, that's our temperature change. And the water, again, I'll put this on the next slide too. We mixed 50 mils with a 52 mils, so the mass of water, 102 grams. So starting temperature 22, maximum temperature 52. So the temperature change of the water in this non-beautiful blue, plus 30 degrees Celsius. Now let's go to the green box to get the calculation of Q. The mass of the water, as I said, 50 grams plus 52 grams. Temperature change right there, 4.18 joules per gram per degree Celsius. Throw those numbers in, and the Q for the water plus 12,791 joules. So the water gained quite a lot of heat. Well, of course it did. It went from 22 to 52 degrees Celsius. Q of the water plus, so Q of the reaction minus, numerically the same, but the water heated up because heat left the reaction. Heat was produced by this exothermic reaction. So now let's go to the purple boxes. And again, a little bit different thought process, but overall the same. We took 2 molar NaOH and we took 0.052 liters, right, 52 milliliters. So we had 0.104 moles of sodium hydroxide. We had 0.05 liters, 50 milliliters of HCl. Again, it was 2 molar, so 0.1 moles of HCl. Now it's a 1-to-1 reaction, so therefore the HCl is the limiting reactant. So we used 0.1 moles of HCl for this reaction. We'd have had some sodium hydroxide left. Okay. By the way, normally we wouldn't actually be looking at the moles of HCl here. We would say 0.1 mole of HCl makes 0.1 mole of water, and that's what we would be using. But of course, exactly the same thing here. So anyway, we got 0.1 moles. Q associated with that minus 12,791. So now our heat of reaction, joules per mole, is 127,910 joules per mole. Divide that by 1,000, put it to a more reasonable level of precision, and minus 128 kilojoules per mole. Hope this helped, and good luck on your exams.